In this video, we are going to learn about solving linear equations. So first, let's review some properties of solving linear equations. So in number 1, I'm going to distribute first. So 5 times x is 5x. 5 times negative 3 is negative 15. Then I'm just going to bring down the rest of the equation. Then I'm going to look to combine any like terms. Well, I have a negative 15 and a positive 6. Those are the only like terms I can see on the left side. On the right side, I don't have any like terms. So I'm going to have 5x, well, negative 15 plus 6 is negative 9. Now, I have variables on both sides. I want variables just on one side. So I could minus the 5x or minus the 3x since they're both positive. I typically like to subtract the smaller numbers. So I'm going to minus the 3x. So I'm going to put 2x minus 9 equals 4. Then my goal is to get the variable alone. So since I have a negative 9, I'm going to add 9. I wrote a little bit too big. So I'm going to put 2x equals 13. Divide by 2, and I'll get x equals 6.5, or you could have said 6.5. All right, let's take a look at the second problem. So my goal is to get the variable on one side. So I have 3/4 x and 2x. And I don't want x on both sides, I want them on one side. And I typically will always move the smaller number, so I'm actually going to minus the 3/4 x. Now, 2 minus 3/4. Well, you can do that in your calculator, or if you want to do it by hand, we're going to do 2 minus 3/4. Well, 2 is the same as 2 over 1. So to get the common denominator, I'd multiply the top and bottom by 4. So really I have 8/4 minus 3/4, which would give me 5/4. So I'm going to have 7 equals 5/4 x minus 5. Now I want to get the x alone, so I'm going to, this negative 5, I'm going to add 5 to both sides because I'm doing that inverse operation. Now I'm going to have 12 equals 5/4 x. So when we have a fraction, to get rid of that fraction, or to get the x alone in this case, I need to multiply by the reciprocal of the fraction. So this, when we talk about reciprocal, that's the flip or the reverse of the fraction. So I'm going to take that fraction, I'm going to take the reciprocal, and I'm going to multiply that on both sides. So again, if I'm doing 12 times 4/5, it's really 4/5 times 12 over 1, which would give me 48 over 5. Or if you did it in your calculator, you might also get 9.6. Either answer is good with me. Our next problem is similar to problem number 2, in which we're going to have a fraction. So just like in number 2, kind of in this middle step here, I'm going to move the negative 6 to get the x alone by adding 6. So I'll end up with 4/5 x equals 36. Then I'm going to multiply both sides by the reciprocal, so that 4/5 is going to become multiplying by 5/4 on both sides. Basically, this becomes 20 over 20, which reduces to 1, and we know 1x is the same as x. So then I'm going to do 36 times 5/4. So again, we could do that in our calculator, or we would think of it as 36 over 1 times 5 over 4. So 4 divides 36, so 9 times 5 is 45. In number 4, I have this 2/5 out in front. Now normally when we have parentheses, we distribute. But if I do 2/5 times 3, I'm going to not get a very nice answer. So instead, I can just do the same thing we did in number 3, where I can multiply by the reciprocal on both sides in order to get rid of that 2/5 in front. So what I'll be left with is just x plus 3. Technically, we'll have a 1 in front times parentheses x plus 3, but I know if I distribute the 1 in, I'm just going to get x plus 3. So if you wrote that step, that's cool. If not, we're just going to write x plus 3 equals 5 halves times 4 is going to give me 10x. Now I have x's on both sides. I don't want x's on both sides. I want them on one side. So since the 10x is already alone on this side, I'm going to minus this x over. Now remember, this is like a 1x. So when I minus this x over, it's really like 10x minus 1x, so I'm going to have 9x. Then I'm going to divide by 9, divide by 9. Now x is going to equal 3/9, but we must reduce. So we do not want to leave our answer as 3/9. We want to leave it as 1/3. We also do not want to do a decimal in this case because 1/3 is a repeating fraction. So it would be 0.3 repeating, which is not as nice as just leaving it as 1/3. So when we have repeating decimals, we want to write them in fraction form. All right, these last couple of examples, I'm going to number them 5, 6, and 7. Are going to yield some different answers, not necessarily numerical answers. So if I look at number 5, this one's a little bit more complicated, but again, starting with the parentheses, I'm going to distribute that 2 in. So I'm going to have 2x minus 12 equals 2x minus 16 plus 4. Now, before I start moving any variables, I'm going to look to see if I can combine any like terms, which I have a negative 16 and a positive 4. So I'm going to have 2x minus 12 equals 2x minus 12. Well, I can already see this is going to turn out a little funky, but I still do have x's on both sides. So I'm going to change that by minusing the 2x from the right to the left. But what happens is I end up with just negative 12 equals negative 12 because 2x minus 2x on both sides is going to give me 0. So since negative 12 does equal negative 12, we're going to call this all real numbers. Or we can use the symbol that's like this double line R. Either of those are good. And it's all real numbers again because the sides are equal. If we look at number 6, similar problem. So I'm going to distribute this positive 2 into the parentheses. This time I'm going to combine like terms, but it's going to be combining x plus 2x. So I'm going to have 3x minus 5 equals, remember this is like a 1x, so 1x plus 2x is 3x minus 12. Now again, we're looking like we're going to be in a similar situation as last time. So if I minus this 3x to both sides, this 3x becomes 0 because 3x minus 3x is 0. 3x minus 3x is 0. So what I'm left with is negative 5 equals negative 12. Now, this is not true versus this one was true. Since it's not true, we're going to say that there is no solution because basically since the two sides aren't equal, there's no number that will ever solve this problem. Versus in number 5, since the answer is all real numbers, that means any number would work. And the two sides are always equal. All right, pause the video now if you haven't already and try number 7. When you're ready, play the video and we'll go over it. All right, so first in number 7, we're going to do some distribution. Now this one's a little bit tricky because there's this negative right here. So what does that negative mean? That negative means that there's really a negative 1 in front of this parentheses that I need to distribute in. So then I'm going to end up with negative 1x, and then negative 1 times negative 8 is positive 8. Let's combine some like terms. So 2x minus 1x is going to give me 1x or x plus 8, and I'm going to 4x plus 20. Now again, I have x's on both sides, so I want to move the x over. So minus 1x minus 1x is going to give me 3x plus 20 equals 8. I want to get the variable alone, so I'm going to minus the 20 to the other side. 3x equals negative 12. Divide by 3, x would equal negative 4. So one of the properties that we use to solve linear equations is distribution. And basically, distribution is just multiplication. And it helps us eliminate the parentheses. So in this case, I had the 10 on the outside, and I distributed or multiplied it into my parentheses. And so I did 10 times x to get 10x, and 10 times 2 to get me 20. The next concept is combining like terms on the same side. So I have a 20 and a minus 10, so that combines to a like term. I can also combine the 2x and the 6x to give me an 8. So when things are on the same side, we're just going to combine them using the operation that's present in order to consolidate like terms. So what I end up with is 10x plus 10 equals 8x minus 4. Now, when we want to get the variable alone, we want to add or subtract to isolate the term with the variable. So I have variables on both sides. I don't want variables on both sides. So I'm going to move the 8x by subtracting it by doing the inverse operation to the other side to get me 2x. Then I want to get that x alone. So I have a positive 10, so I'm going to subtract 10 to then get the variable alone. My last step is to multiply or divide to isolate the variable. So we're always going to do the inverse operation. So in this case, I have 2. This is the same as 2 times x. So to isolate the x, I'm going to divide by 2 on both sides, and that's how we get x equals -7. So let's put some of these properties into action.